Hello, here is section 9.3. For algebra, we are graphing quadratic functions in this. And as we can see, this is yippee, hooray, fun. It'll be so exciting. I know you guys are all rolling your eyes, but yippee, hooray, I love graphing quadratic functions. It's so much fun. So here we go. What we're going to be paying attention to a little bit for this first little part is the Y-intercept. It's just another point that we can find on a graph that'll help us identify our quadratic function and where it needs to cross in various places. So the y-intercept is where the graph intersects the y-axis. So similar to our y equals mx plus b format with slope-intercept form, this b is the y-intercept. Well, when we look at our y is equal to ax squared plus bx plus c, our y-intercept is our constant term. It's that sort of flat rate that you have at the end of your parabola. So in this example, y is equal to x squared minus 2, we can see that this graph crosses at a negative 2. And so therefore, our y-intercept is equal to 2, or equal to negative 2. So that would be potentially an answer if you had to answer what is the y-intercept. So now let's go into this. How to graph a function. How to graph a function. There's a few steps that we can go through. Our very first step, I'll get this nice and big. Our very first step is to find the axis of symmetry. So we're looking at that x is equal to negative b over 2a. So looking at that formula, not formula, formula. The next step is step number 2, which is to find the vertex. We know what we get out of that y equals mx, or that x is equal to negative b over 2a. That ends up being our x-intercept because our vertex is always going to be on our axis of symmetry. And if we were to put that into our equation, that y is equal to ax squared plus bx plus c, whatever that may look like, if it's 2x squared plus 4x plus 9, whatever it may be. If we put that in there, our result will be our y for that vertex intersection. Step number 3 is to find the y-intercept, and we know that now that our y-intercept is just that c sort of constant term on the end of our equation. And our last step, step 4, is to find a couple more points that could work for the graph. So now we're going to actually graph a function, okay? So let me zoom out here so we can see our function that we're going to graph. Let me zoom way out so I can really see it even more. Here we go. Here's our function. We have x squared minus 4x minus 5. So our first job, we need to find our axis of symmetry. And we are going to do that in purple. So our axis of symmetry is that x is equal to negative b over 2a. So our a term in this case is a 1, our b term is a negative 4, and our c term is negative 5. So negative b, which is a negative 4, over 2 times 1. So what I see here is I see 2 times 1, which we can do as 2, and negative negative 4. So I see a negative, and we're going to make those both positive, so we just have simply 4. Negative 2, or 4 over 2 equals 2. So our x-intercept of our vertex, as well as our x for this particular case, is a positive 2. And so we can then graph that on here. And I actually might have to zoom into this really quick. Let me zoom in here so we can get that on here. Our axis of symmetry is along this x at axis of symmetry. Is that x is equal to negative, or equal to positive 2, not negative 2. Positive 2. Okay, now we'll zoom back out a little bit so we can see the rest of it. Our next couple of steps, we need to find the vertex. So we're going to take this information right here that we have, this 2, and we're going to plug it into our original equation. We're going to put it right in there. So we have 2 squared minus 4 times 2 minus 5. Let's do a little bit of math. we have exponents. 2 squared is 4. And then we have this math right here. 4 times 2 is 8, so we have negative 8, or subtracting 8, minus 5. So 4 minus 8 is negative 4, minus 5 equals negative 9. So our vertex is the point 2, because we're taking that from our axis of symmetry. Our vertex always lies on our axis of symmetry, and negative 9. So there's our vertex. Zoom in here again and actually do that to negative 9. There is our vertex to negative 9, and if you notice I'm labeling that. Next step, we need to find the y-intercept, and if we were to actually look at just that ax squared plus bx plus c format, and if we looked at this x squared minus 4x minus 5, our a is 1, our b is negative 4, and our c is negative 5, so there is our y-intercept at negative 5. Let's zoom in on this baby and actually get that marked on. So there's our y-intercept, and what's interesting is because that is on one side of the axis of symmetry, we can actually just go over 1, 2 to get to the axis of symmetry, 1, 2 away from it, and now we have one more point. That's kind of cool. Last little step, we need to find a couple more points to graph that function, and we can do that with simply a table, or we can just pick a number. It looks like we don't know what x equals 1 could be, and that could potentially help us. So if we have that, or if we use x equals 1, we can put that in there, and we can say 1 squared minus 4 times 1 minus 5. 1 squared is 1, minus 4 times 1 is 4, minus 4, minus 5 equals 1 minus 4 is negative 3, minus 5 is equal to negative 8. So at x is equal to 1, we have y is equal to negative 8, and we can now graph that. And as we know, axis of symmetry is a direct reflection, so we can add that in there. And now we have a pretty good graph. Let's do one more a little bit further up. Let's do negative 1 and just see if we can get a little bit more accuracy here. So if we had x is equal to negative 1, what is the corresponding y? So we have negative 1 squared minus 4 times negative 1 minus 5. Negative 1 squared is a positive 1. Negative 4 times a negative 1 equals plus 4, and we're subtracting 5 from that, so we have 1 plus 4 is 5, minus 5 is equal to 0. So our y, that should have been y is equal to 0 when x is equal to negative 1. So we can rewrite that, and our last point, we can rewrite this as a coordinate pair 2. Let's get that on our graph. At x is equal to negative 1, we have a 0 point, so that's one of our zeros. That's cool. And we can do the same thing over here for 5. Now, last little bit, let's graph this. Let's actually get it all lined up with pretty little graphs. So our parabola kind of looks like that when we're all said and done. We have now graphed our parabola. Kind of cool. So this parabola, y is equal to x squared minus 4x minus 5, that graphs into this beautiful parabola. So we can label this all. Y is equal to x squared minus 4x minus 5. That is this graph. Okay, so the last portion of this lesson includes problem solving. And with problem solving, we can do the same sort of thing as what we were doing before, having these various steps of finding the axis of symmetry and the vertex and the y-intercept. But being able to identify what these things are in a word problem is incredibly important. So we have this problem right here. The height and feet of a football kicked by Dixon. He's going to star in this little problem. So Dixon's kicking a football can be modeled by the function f of x is equal to negative 16x squared plus 64y, or plus 64x, where x is time in seconds after it is kicked. And it should say seconds. I'll put an s in there. Time in seconds after it is kicked. find the football's maximum height and the time it takes for the football to reach this height. Then find how long the football is in the air. So Dixon kicked a football, and actually what is kind of interesting is gravity can be modeled by this -16 and this 64, as well as the acceleration of the football when it actually gets kicked into the air. So that is the only reason why this particular situation is set up. So think this is the situation for gravity, and you might have other situations that you have to model it with this same function. So we have f of x is equal to -16 x squared plus 64. And we need to pay attention to, for this particular problem, 3 different things. This problem is asking us for 3 different things. We need to find the maximum height of the football, the time it takes to get there, and then how long is the football in the air. So essentially we can write this as the maximum height, and the time it takes is essentially our vertex of our parabola. We need to find the vertex, and this, because we can see that it's a -a term, it is a parabola that's pointed down, so it's something like this, which makes sense. I mean, the trajectory of a football, it's kind of a rainbow shape versus upside down. Dixon's not going to be kicking a football like that, I sure hope. So we have a parabola that's kind of shaped like that, so we need to find the vertex, and part of that vertex is going to tell us time, and the other part of the vertex is going to tell us the height. And the reason why I set it up as time in the x-coordinate is it says x is the time in seconds after it's kicked, so x-coordinate is time. As well, we need to find out how long the football is in the air, so what is the time total that is in the air? So that's also something we need to find, which we can figure out given maybe the axis of symmetry. So axis of symmetry will help us with this. That'll be helpful. So first of all, let's actually figure out the axis of symmetry. We have our A, which is -16, and we have our B, which is 64, and our C in this case is 0. So that means our Y-intercept is at the ground, 0 meters. Is it meters? Doesn't say. No, feet. 0 feet. So our y is at 0 feet, our y-intercept, so Dixon's, this is essentially starting at one point, like right at the origin. And what we can do after that is we can actually figure out the axis of symmetry. So our axis of symmetry is x is equal to -b over 2a, which is equal to -64 over 2 times -16. So -64, 2 times -16 is -32, so we get a positive 2 seconds. That tells us at 2 seconds, our football is at its max height. So axis of symmetry is at x equals 2. X equals 2 seconds. Okay, so now when the football is 2 seconds in the air, we need to figure out the max height. So I'm actually going to do, well, I guess I can't do that. I was going to erase this time is equal to 2, but I can't quite do that. Nope, I can't do it. So at 2 seconds, it's at its maximum height. So we need to put this information into the original equation. Let's zoom out here so we have a little bit more room. So our original equation, that -16 x squared plus 64x, will get us our height of the football being off the ground, and we decided 2 seconds was where it was going to be at its max. So we have 16 times 2 squared plus 64 times 2. 2 squared is 4 times -16. We can do that math, that is -64, and 64 times 2 is equal to positive 128. So if we were to do -64 plus 128, we get a positive 64 feet. So its height, when Dixon's kicking the football, he can kick it 64 feet in the air. Awesome. 64 feet. Pretty sweet. Now, last but not least, we need to figure out how long it's in the air total. To get to its halfway point, it takes 2 seconds. To get to the rest of the point, or to get to the end, it's going to be 2 more seconds. So total, we have 4 seconds. So, to finally say all of this, we can say Dixon kicked the football to max height 64 feet, took 2 seconds, and the football was in the air for 4 seconds total. Awesome. So this is a sort of problem-solving application that you may have to do. Keep this in mind. I hope this whole video helps. Let's hope that the homework goes okay tonight. Thank you very much for listening, and I'll see you tomorrow.